Ever stop and think about what's holding our world together? I mean, literally. Today we're going to pull back the curtain on the field that shapes everything from the ground we walk on to the skyscrapers that touch the clouds. We're talking about civil engineering. No, seriously, think about it for a sec. The moment you step outside your door, you're plugging into this massive, complex system. And none of it happened by accident. It was all planned, all built with a purpose. You know that highway you take every morning? The one that gets you to work? Or that web of city streets you navigate to get back home? Yeah, that, and even the clean water that just magically appears when you turn on the faucet. It's kind of crazy, right? How does all of that stuff just work? Well, that's where civil engineers come in. They're the masterminds, the architects of our world. We're talking about the folks who design, build, and keep the whole show running. They're the ones behind the very foundations of our modern lives. Okay, so we've established they're pretty important. But what does a civil engineer actually do? What's all included in this massive field? Let's dive in. So, here's the official definition. But really, it's one of the oldest and, honestly, most diverse types of engineering out there. When you boil it all down, it's about solving really tricky problems to make our lives better, using all the stuff we totally take for granted every single day. And just look at this list. It really shows you how massive this field is. We're not just talking about one thing. It's buildings, bridges, roads, airports, even the dams and water systems that give us power and clean water. They really are the backbone of society, no question about it. So you might be wondering, how in the world do they pull all this off? What's in their secret toolkit? Well, it all starts with the basics, the core sciences. I love this breakdown because it makes so much sense. You've got two main pillars, right? Math is the how much. It's all about calculating the weight, the pressure, the stress on a structure. Then you've got physics, which is the how. It tells you how your materials, your steel, your concrete are going to react to all that stress. And you can't have one without the other. They're a team. And it's not just math and physics. Oh no, you've also got to bring in chemistry to understand the stuff you're building with, like what makes concrete strong. And geology is huge because it tells you about what you're building on, the soil, the rock. You have to understand the whole picture. Okay, so since this field is so huge, it makes sense that it's broken down into different specialties, right? Let's take a look at a few of the big ones. First up, you've got structural engineers. These are the people who make sure our skyscrapers don't topple over and our bridges don't collapse. They're constantly battling forces like wind, gravity, even earthquakes, all to make sure we're safe. All right, now let's go from the sky down to the dirt. Geotechnical engineers are basically earth whisperers. They study the soil and rock to make sure the ground won't just give way under the enormous weight of a building or a tunnel. Super important stuff. Then we have transportation engineering. This is all about motion, keeping people and things moving. They're the ones designing our highways, our train systems, our airports. Their whole goal is to make sure everything flows smoothly and, most importantly, safely. And this next one, it's more important now than ever. Environmental engineers. They're really on the front lines of protecting public health and our planet. Think clean water, waste management, and figuring out how to build all this stuff without wrecking the environment. It's a massive job. Okay, so we've got all these different experts. How do they work together to take a project from just an idea on a piece of paper to a real physical thing? Well, there's a roadmap they all follow. It all starts with the problem, right? Like, hey, we need a new bridge here. Then they gather a ton of info about the site, the materials, the rules. They analyze everything to figure out the best way to do it. Then comes the fun part, the design, where they create the actual blueprints. After that, it's time to build. But, and this is key, it doesn't end there. They have to keep an eye on it, maintain it, to make sure it stays safe for years and years to come. But you know, just following the steps isn't enough anymore. A truly successful project today is about more than just steel and concrete. It's about building a better future. Yeah, sustainability isn't just a buzzword here. It's baked into the DNA of modern engineering. The challenge for engineers today is to build things that work for us now without messing things up for our kids and grandkids. It's a huge responsibility. And that's why being a top-notch engineer today is about so much more than being good at math. You gotta have what people call soft skills. You need to be able to communicate your ideas clearly, work with a whole bunch of different people, and manage massive projects to keep them on track. Honestly, these skills are just as crucial as the technical ones. And this quote, it just hits the nail on the head. Civil engineering is all about shaping our world. The things you build can make a real, lasting difference in people's lives. It's pretty powerful stuff. So that leaves us with one last question. Think of the world as this giant, ongoing construction project. The blueprint is always changing. So the real question is, what are you going to build?